Have you ever used a compass? That little needle always pointing north? It's not magic, it's tapping into a giant invisible force field that surrounds our planet. This is Earth's magnetic field, and it's way more important than just helping us find our way in the woods. But here's the wild part. This field isn't stable. It's dynamic. It wanders. And sometimes, it completely flips. What would that mean for us? Let's dive into one of the most mind-bending phenomena our planet has to offer, the coming magnetic pole reversal. So, what exactly is this magnetic field? Picture the Earth not as a solid rock, but as having a fiery, liquid metal heart. Deep inside, about 1,800 miles beneath our feet, there's a core of molten iron and nickel, churning and swirling like a cosmic pot of soup. This movement of liquid metal creates powerful electrical currents, and just like any electrical current, it generates a magnetic field. This process is called the geodynamo. Think of it as Earth having a giant bar magnet stuffed inside, with a north and a south pole. This field extends thousands of miles out into space, creating a protective bubble called the magnetosphere. And this bubble is our planet's unsung hero. It acts like a planetary shield, deflecting most of the charged particles that the sun constantly blasts our way in what is known as the solar wind. Without the magnetosphere, this stream of high-energy particles would strip away our atmosphere, including the ozone layer that protects us from harmful ultraviolet radiation. Life as we know it simply couldn't exist. Mars, for example, is thought to have lost its global magnetic field billions of years ago, which is a key reason its atmosphere is so thin and its surface is barren and exposed to deadly radiation. So, yeah, our magnetic field is a pretty big deal. Now, let's talk about the flip, or what scientists call a geomagnetic reversal. This is when the magnetic north and south poles swap places. The compass needle that points north today would, after a reversal, point south. This sounds like something out of a disaster movie, but it's a completely natural and recurring process. By studying ancient rocks, particularly volcanic lava flows, scientists have built a timeline of Earth's magnetic history. When lava cools, magnetic minerals within it align with the planet's magnetic field at that moment, like tiny fossilized compasses. This geological record shows that the field has flipped hundreds of times over millions of years. The last full reversal happened about 780,000 years ago. That might sound like a long time, but geologically speaking, it's not. The average time between reversals is about 200 to 300,000 years, so some might say we're a bit overdue. However, overdue is a tricky word here. The process isn't like a ticking clock, it's irregular. We've had periods of tens of millions of years without a flip, and other times when they happened more frequently. What we do know is that we seem to be in the early stages of something happening right now. For the past couple of centuries, scientists have been measuring the strength of the magnetic field, and they've noticed it's weakening. It has lost about 10% of its strength since the 1800s. At the same time, the magnetic North Pole isn't just sitting still. It's been wandering away from its historical position in the Canadian Arctic, and is now racing towards Siberia at an accelerating pace of about 30 to 40 miles per year. This movement is so rapid that geophysicists have had to issue emergency updates to the World Magnetic Model, which is what our GPS systems from our phones to airplanes rely on for accurate navigation. So what happens during a flip? It's not an overnight switch. The process is messy and can take thousands of years. During this transition, the main magnetic field, which is currently dominated by a simple north-south pole structure, would become much weaker and more complex. Instead of one strong north and one strong south pole, we might see multiple, weaker local poles popping up all over the globe. Your compass would be useless, spinning around erratically, trying to find a dominant pole that no longer exists. The main shield, our magnetosphere, would be significantly weaker. What are the real-world consequences of this? Let's start with technology. A weaker magnetic field means more solar radiation can penetrate deeper into Earth's atmosphere. This would be a major problem for our satellite-dependent world. Satellites for communication, GPS, and weather forecasting would be more vulnerable to damage from high-energy particles. We could see more frequent and widespread power outages as geomagnetic storms, which already happen today, become much more intense and induce powerful currents in our electrical grids. Basically, anything with a circuit board could be at a higher risk. And what about life on Earth? The increased radiation reaching the surface would be a concern. While our thick atmosphere would still offer a lot of protection, there could be a slight increase in radiation levels at the ground. This might lead to higher rates of certain types of skin cancer. Some animals that use the magnetic field for navigation, like migrating birds, sea turtles, and whales, would be profoundly confused. They might struggle to find their breeding or feeding grounds. It would be like taking away their internal GPS. They would likely adapt over generations, perhaps relying more on other cues like the sun or stars, but the initial transition period would be challenging for them. Now, before you start building an underground bunker, let's get some perspective. A geomagnetic reversal is not an extinction-level event. The fossil record shows no evidence of mass extinctions being directly linked to past reversals. Life, in its incredible resilience, has weathered this storm many times before and continued to thrive. The process is slow, unfolding over thousands of years, giving both nature and, hopefully, human civilization time to adapt. We won't wake up one morning to find the poles have flipped and the world is in chaos. So what are we doing about it? Scientists are monitoring the situation with a global network of observatories and satellites, tracking every little change in the magnetic field's strength and direction. This data helps us refine our models and better predict what might happen next. For our infrastructure, engineers are working on ways to harden our power grids and satellites, making them more resilient to geomagnetic disturbances. This includes developing better shielding and creating smarter systems that can quickly shut down and restart to avoid catastrophic damage during a solar storm. The next magnetic flip isn't a question of if, but when, and while when could mean 1,000 years from now or even longer, the changes happening right now are a fascinating reminder that we live on a dynamic, ever-changing planet. It's not a doomsday scenario, but a planetary-scale challenge that we are becoming increasingly equipped to understand and prepare for. It's a testament to human ingenuity that we can study these vast, invisible forces and plan for a future far beyond our own lifetimes. So the next time you use your phone's GPS or see a beautiful aurora in the sky, take a moment to appreciate that invisible magnetic shield wrapping around our world. It's our planet's protector, and its slow, epic dance is one of the grandest shows in the solar system. Thanks so much for watching. If you found this journey to the Earth's core interesting, don't forget to hit that like button and subscribe for more deep dives into the amazing science of our world. See you in the next video.